So in this video we will cover how the popular GPT architecture works. As we discussed in the previous video, one important concept of transformers is to pre-train them using self-supervised learning. So for step 1, the pre-training, we have two different options, either predicting randomly masked words or predicting the next word. GPT takes the second approach where we predict the next word in a sentence. But before we talk in more detail how the pre-training works in GPT models, note that there are many different types of GPT models out there. There are the original GPT 1, 2, and 3 models, with the first GPT model introduced in 2018. Then GPT-2 was introduced 1 year later, and in 2020 there was the GPT-3 architecture, which is still very popular as the basis for many other types of transformers. For example, InstructGPT and ChatGPT are based on GPT-3, but they are just fine-tuned in a slightly different way. Now, what's interesting about these different types of GPT models is that each time they are getting bigger. So with GPT-1, we started with 10 million parameters, and in GPT-2, we already have 1.5 billion parameters. So each parameter here would be a tunable weight in the architecture. Now, GPT-3 has 175 billion parameters. Interestingly, InstructGPT and ChatGPT are not bigger than GPT-3 because they are based on the same architecture. They are just fine-tuned slightly differently. And yeah, if you want to read more about these different types of architectures, here on the right-hand side you can see the paper titles for reference, and we will also include links to these papers in the additional materials. Now, what are GPT models? So GPT models are generative models as opposed to classifiers. So GPT models are usually used to generate texts. So here, for example, I prompted ChatGPT to create a recipe for a banana smoothie. But how does this architecture of the GPT approach look like? Actually, it's something you are already familiar with, because the GPT architecture is essentially the decoder part of the original transformer. Of course, just slightly bigger. The novelty here is how it's pre-trained. So the GPT architecture is pre-trained by predicting the next word. So it's really just an unlabeled data set where we mask one word at a time, and the GPT model has to predict the masked missing word. And yeah, this next word prediction is essentially the self-supervised pre-training task used in GPT models. Note that while GPT models are mainly models used nowadays for generating text, we can do actually a lot of things with GPT models when we consider the output embeddings. So for example, we can use also GPT models for classification. They are just not the best at classification. There are a few other architectures, as we will see later, that are a little bit better suited. But yeah, we can also, of course, train GPT models to, for example, perform tasks like similarity recognition or multiple choice selection. It really just depends on how we fine-tune it to the target task. And like we mentioned before, there are two different ways we can adopt a pre-trained transformer to a target data set. There is the feature-based approach and there's the fine-tuning approach. So for the feature-based approach, we don't update the weights of the model. What we do is we directly work with the output embeddings. So we pass these output embeddings to a classifier or an output layer that we itself train or tune, but we don't update the main language model. So to clarify this concept, you can think of this classifier also as a non-neural network model. For example, it can be a random forest or an XGBoost model. And we really just use the language model to create the input features for this machine learning model here. The second approach is the fine-tuning approach, where we add one or more layers to the model depending on the task. And then during fine-tuning, we either update the weights in the output layers or the complete language model. Now, technically speaking, GPT-2 and 3 don't strictly require fine-tuning because they are also capable of in-context learning using so-called zero or few-shot learning. So what is zero or few-shot learning? So let's take a look at how zero-shot classification works in the context of ChatGPT. So here I'm prompting the language model to translate this word from English to German. Note that ChatGPT has not been explicitly trained to do the translation, so zero-shot here means that it can do the translation without having seen previous examples. A one-shot example here is where we at least include one example of the task that we want to perform. And now a few-shot example is where we give multiple examples of the task that we want to perform. So in this case, I'm giving ChatGPT multiple examples of adding two numbers to see if it can add two new numbers. Actually, also as a side note, if you are interested in training your own GPT model, we do have a recipe for that at Lightning, which I will share also in the further resources. So what about InstructGPT and ChatGPT now? InstructGPT and ChatGPT are actually based on GPT-3, but they have been fine-tuned additionally using human feedback. So how does that work? So in step 1, the researchers sampled different prompts from a database and asked humans to write the responses that are desired. And then these desired responses are used as essentially target data to fine-tune the GPT-3 model in a supervised fashion. And then in the second step, the fine-tuned model is used to generate responses for different inputs, and humans have to rank the quality of the response, including the human-written responses. So you end up with a ranking of the human-generated responses and the machine-generated responses. These rankings are then used to train a so-called reward model, a second model, also using supervised learning. And the goal of this reward model is to generate this reward signal, the ranking score, for example, for new generated texts. And then this reward model is used in a reinforcement learning context to further fine-tune the fine-tuned GPT-3 model to become even better. And yeah, this is in a nutshell how GPT works, with a two-step process of pre-training and fine-tuning. And in the next video, we will take a brief look at a large language model for classification in contrast to generating text.